Okay, we're going to be looking at properties of logarithms, and you have access to this reference sheet in the Document Sharing Center in my math lab. What I want to point out to you in this table is the product, quotient, and power rules for exponents and logarithms and how they relate. Remember that logarithms are exponents. When you're looking at the product rule, you're adding the exponents, so you're adding the logarithms. If you have a quotient, you are subtracting the exponents. And the power rule says when you have power raised to a power, you multiply the exponents. So I'm multiplying this exponent n times the log of m. Okay, so looking at these first couple of problems here, the first thing that I'm asked to do is to evaluate a couple of these expressions like we have been doing on the previous lesson. Log base 9 of 9 to the 7th power. This is saying if I take 9 and raise it to a power, I want to get 9 to the 7th power. What exponent do I need? Well, I need 7. Another way to think of this as I have a base of 9 here and a base of 9 there. I've got a log with a base 9 and an exponent of base 9. And those are inverses of each other, and inverses sort of cancel each other out. Same thing over here. I've got an exponent of 4, a power with a base of 4 and a log with a base of 4. And these are going to cancel each other out, and I get 9 for the answer. All right, this next section says to use the properties of logarithms to rewrite the expression. So problem number 3, I want to take this product here of the two numbers, and I'm going to write this as the sum of two logs using my product rule. I'm going to have the log base 5 of 14 plus log base 5 of 6. In problem 4, I've got a quotient. So I'm going to be subtracting the two logarithms. I have n x, a power rule. So I end up with 5 times the log. And one way to think about this is to take that exponent and just move it up in front of the logarithm. Okay, so those are 3 of the properties of logarithms that we have looked at. And problem number 6 doesn't seem like it matches up with any of those properties. Excuse me. But what you need to remember is that a cubed root is the same thing as the 1/3 power. So I can write this as log base 5, 18 to the 1/3 power, and then use my power rule, take that 1/3 and move it up front of the logarithm. So I have 1/3 log base 5 of 18. So we're going to be using all 4 of these properties here to expand logarithms. So problem number 7, here I'm using more than one of these properties to expand this. So I'm going to first of all write this as the sum of 2 logs. So I have log of 5 plus the log of 6 squared, and both of those with the base of 4. Now I can take this 2 and move it up front of my logarithm here using my power rule. So I have log base 4 of 5 plus 2 log base 4 of 6. Now It says to use the power rule for exponents first. Now, I could do this problem a couple of different ways, but if I use that power rule first, I think it's going to be a little bit easier. First thing I'm going to do is write this 5 and 6 as 5 to the first and 6 to the first. Then use my power rule for exponents, which says that the exponents inside the parentheses get multiplied by the exponents outside the parentheses. So I have 5 squared times 6 squared. And notice that that is all there in parentheses. Then I'm going to write this as the sum of 2 logs of log base 4 of 5 squared plus log base 4 of 6 squared. Then I can use my power rule and put the exponents up in front of the logs. So I have 2 log base 4 of 5 plus 2 log base 4 of 6. Problem number 9, I have a quotient. I'm going to use the quotient rule, which means I'm going to end up with the difference of 2 logs. And on this second logarithm, I have 9 to the third. So I can use properties again and take this 3 and move it up front of that log. So when I have the log 2 base 2 of 7 minus 3 times the log base 2 of 9. All right, problem number 10. What I'm going to do here is use the quotient rule. So I'm going to write this as the difference of 2 logs, log base 8 of 3 minus the log base 8 of 4x. And now what I'm going to do is to take this 4x and split this up into log of 4 plus the log of x. But when I do, I have to be sure that I've got parentheses around everything that I'm subtracting. We've done a whole lot of problems with polynomials and understanding the importance of that parentheses. It's going to be the same thing here. Now, when I drop the parentheses, I'm going to distribute that subtraction sign all the way through. As I'm subtracting the 4 and I'm subtracting that x. Okay, now what I want you to see from here is that the 2 terms that are in the denominator, the 4 and the x, both get subtracted. So that's what happens on all of these problems that are a little bit more complicated. If you just realize that everything that's in the numerator is added and everything in the denominator gets subtracted, it makes the problems go a little bit quicker. So when we get down here to problem 12 and I have the square root of 11, I could write that, you know that you're going to have to write the square root of 11 as 11 to the 1/2. You could do that at the beginning problem or you could do that toward the end of the problem. It doesn't matter. So let me give you a minute to try to do problems 11, 12, and 13 on your own. Okay, and there's problem number 11. Notice that the 3 and the a are in the numerator. They're added. The b and the 5 are both subtracted because they're in the denominator. Over here on problem 12, I have the 7 and the m are both being subtracted. And notice that m is going to have a 2 for an exponent associated with it. The 7 does not have the exponent associated with it, so there's no 2 up front here. Problem 13, we have to write those radicals, and exponent form, and then we can bring those exponents up front. Okay, problem 14, there's a couple of different ways that I could go about doing this. I'm going to first of all write this as 3x over 7 in parentheses to the 1/2 power. And from here, there's a couple of different things that I can do. I can bring the 1/2 out front, and then I have 1/2 times the log. I could split that up into log of 3 plus the log of x minus the log of 7, and then I would have to distribute that 1/2. Another way to do it is to use my exponent rule first. So I have 3 to the 1/2 power times x to the 1/2 power, and that's going to be divided by 7 to the 1/2 power. And then I can use my product rule and quotient rule and write this as the sum and difference of the logs. So log of 3 to the 1/2 plus the log x to the 1/2 minus the log of 7 to the 1/2 power. And then all of those exponents come up front. So I have 1/2 log base 9 of 3 plus 1/2 log base 9 of x minus 1/2 log base 9 of 7. Okay, this next one thing I want to mention before I go on to that next part is that your homework in my math lab and on the test, the problems are going to be multiple choice. So you don't have to worry about typing all of that stuff in, because that gets a little bit tedious to type that all in the computer. All right, this next part is looking at taking different logs and combining them with into a single logarithm using my properties. So here I have the sum of two logs. That is going to be simplified by using the product rule. So I'm just multiplying these two arguments together. Problem 16, I have a subtraction of two logs. So I can write this as log base 3 of 7 divided by 2, write it as a quotient. And here, number 17, I've got the sum of two logs. And notice that I've got variables here, or binomials, and we're not limited to just one term within this argument. So I'm going to be multiplying these two together. So I'm going to write this in brackets. I'm going to have x plus 1 in parentheses times x minus 5 in parentheses and the whole thing in the brackets. So now I can go ahead and multiply that out. And I'm going to get x squared minus 4x minus 5. And problem 18, I'm going to be using my power rule. I'm going to take this 2 that's up front, and I'm going to put that as the exponent of the 7. So I'm going to have log base 5 of 7 squared. Now the next problem here, I have to remember order of operations, that I need to do what's inside these parentheses first. So I have log base 5 of 6 minus the log base 5 of 7a. As the 7 and the a are added, I could write it as the product of 7a. And now I have the difference of two logs, so I can write that as a quotient. 6 divided by 7a. And right here on problem 20, I could do this a couple of different ways. I could follow the order of operations, please excuse my dear Aunt Sally, do what's in parentheses first. Or I could drop the parentheses and just do the shortcut, realizing that whatever is added goes in the numerator, whatever is subtracted goes in the denominator. I could have done that on problem 19 as well, but I can't just drop the parentheses up here. I have to distribute that negative. I'm going to go ahead and do this out step by step. This is the log base 5 of 6 divided by 7 plus the log base 5 of a. Now I've got these two things that are being added, so I can just multiply these together. So that gives me 6a over 7. And this next problem's a little bit longer, but it's still, using the same properties. So I'm going to have the log base 5 of 2 cubed. I'm just taking this 3 and moving it to the exponent of the 2, plus the log base 5 of 6 minus the log base 5 of 4 to the 1/2 power. I'm just taking this 1/2 and moving it to the exponent here. So this is going to be the log base 5 of 8 plus the log base 5 of 6 minus the log base 5 of 2, right? 2 cubed is 8. 4 to the 1/2 power is the same thing as the square root of 4, which is 2. Now, I'm going to combine these first two terms, and using my rules or laws of logarithms, I'm going to be multiplying these two terms. 8 times 6 is 48. And then I'm going to combine these two logs into one log. And when I have subtraction and I combine them into one, I'm using the quotient rule, so I'm going to be dividing. I'll have 48 divided by 2. So that's going to be 24. Problem 22, I want you to pause the video and try that one on your own. Okay, there's your answer for problem 22.